A lot of RAG failures are not retrieval bugs. They are bad documents that should have failed validation before indexing. You'll learn how the pieces fit into a workflow that flags bad documents before they enter search. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. RAG pipelines often break for the wrong reason. Folks point at the model or the retriever when the real culprit is junk in the index, missing text, duplicate IDs, and mislabeled sources turn a vector store into noisy garbage. Great Expectations sits nicely before indexing. You write readable rules, run them on a small ingestion manifest, and stop bad pages before they become vectors. On real projects that trims bad retrievals and misleading citations by removing dead signals from the index. At a practical level, we need a checklist that runs on each document before it becomes a vector. Picture a tiny manifest table where each row is a page. We check that text exists, doc IDs are unique, and file names look like the inputs we expect. The payoff is clarity and repeatability. The downside is you must pick checks that match your corpus. We'll build a compact pre-index gate. Start from a small pandas table that looks like an ingestion manifest. Connect it to Great Expectations. Run focused rules, prioritize failures, clean the rows, and package the checks as a reusable gate your pipeline can call. No magic, just clear rules that stop bad pages early. Quick note: this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. Now we create the simplest manifest so the validation inputs are obvious. This snippet creates the smallest pandas data frame that looks like a RAG ingestion manifest. Before Great Expectations enters the flow, the input needs to be obvious on screen. One page has useful text, 2 pages are empty, and 1 page has table-like text. The docs table keeps the fields engineers usually care about before indexing: doc ID, file, text, and source. The computed empty text count gives a quick baseline for what the validator should catch later. The visible output shows the raw page count and the empty text problem that could otherwise reach retrieval. With a manifest, we need to connect it to Great Expectations and assert simple rules about text. This example connects the pandas docs table to Great Expectations and validates that each page has indexable text. Empty chunks are dangerous because they still consume IDs, metadata, and sometimes vector slots without adding retrievable evidence. The code creates a context, registers a pandas data source, builds a whole data frame batch def, then calls batch validate with gxe, expect column value lengths to be between. Setting min value equals 1 makes the rule strict enough to catch blank strings while allowing any non-empty text length. The visible output shows Great Expectations found 2 rows that should not be indexed. Finding one problem is useful, but we also need to know which problems matter more so we can prioritize cleanup. This code compares 2 common pre-index failures instead of treating validation as one pass or fail blob. Missing source values make citations and debugging harder, while duplicate doc ID values can overwrite or double index the same page, depending on the vector store. The checks dictionary holds 2 Great Expectations objects, and the comprehension runs each one through batch.validate. By collecting unexpected count, the code can rank failures and show which rule needs attention first. The visible output names the largest failing rule and its row count, which helps prioritize cleanup before retrieval tuning. After you know what fails, the next step is to perform lightweight cleaning and revalidate before anything ever reaches the index. This snippet turns validation findings into a small quarantine step before anything reaches the index. The code removes repeated doc ID values, trims text, and keeps only pages with non-empty text. Then, Great Expectations validates the cleaned batch with GXCE expect column values to match regex, checking that the remaining file values look like PDF inputs. This is not a full PDF parser. It is a lightweight file name contract for the ingestion manifest. The visible output shows the clean set is smaller and passes the PDF name rule, which is the batch you would send downstream. Finally, you want a stable gate object you can call from your orchestration before embedding or indexing. This example packages the final pre-index checks into a reusable Great Expectations gate. One-off batch.validate calls are useful while developing rules, but a RAG pipeline needs a stable object it can run before indexing. The code creates an expectation suite, adds metadata and identity checks, then binds that suite to batch def with gx.core.validation definition. Calling gate.run on clean docs produces a single success signal that an orchestrator can use to continue or stop the job. The visible output shows whether the clean documents are ready for indexing and how many rules protected the handoff. This toy flow maps easily to a production job. The manifest scales to thousands of pages, and the same gate can run inside a Kubernetes step, an Airflow task, or as a pre-commit check for your ingestion repo. Keep the check small and explainable, so engineers can triage failures quickly. This is a pre-index validation gate using Great Expectations that stops bad rows from becoming vectors. Run it before embedding or indexing, especially if hallucinations seem tied to broken source content. One caveat: your rules must match your corpus, and overly strict checks will reject useful edge cases. A concrete next step is to tune your retrieval index for the cleaned corpus. Try adjusting FAISS endprobe on the actual index built from this manifest to balance recall and latency. Measure retrieval recall before and after the gate, and adjust endprobe until you hit your latency target. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.